This tutorial is going to cover how to conduct a one-way within subjects ANOVA in SPSS. You should have already checked your data to confirm that it does not violate any of the assumptions of an ANOVA. I have created a video already looking at the ANOVA assumptions. It is really important that you spend a little bit of time before doing analysis like an ANOVA just to check this out. So what is a one-way within subjects ANOVA? It's also known as a repeated measures ANOVA. I'll tend to use these words interchangeably. But I am talking about the same thing. A one-way within subjects ANOVA, or a repeated measures ANOVA, is used to determine if there's a statistically significant difference between the means when participants are in the same group. It could be that participants are measured on more than one occasion to see if the effect of an intervention is working, or participants could have taken part in more than one condition of an experiment. It is most common to do the ANOVA for 3+ means, as I have in the example here. So let's get my data up and you can have a look. So you'll see here, this is my data. You'll see that I have the dependent variable, which is the number of words recalled. So that's what all of these numbers refer to, is the number of words a participant recalled. This is what I'm interested in measuring. The independent variable, or the factor, is the noise level in the room at the time of the experiment. So you'll see in some conditions it was quiet, some it was medium noise, and some participants were exposed to a loud noise whilst they were recalling the words. So there are 3 levels here: quiet, medium and loud. So in my experiment I had 8 participants, you can see that's here. So participant 1, this was their score, this was how many words they recalled in the quiet condition, the medium and the loud. Participant 2 recalled 9 words when it was quiet, 5 when it was medium, 2 when it was loud, so on and so on. So what I want to know is, does the amount of noise in the room affect the number of words recalled? So to do this, I'll run the analysis. So we click on Analyse, General linear model, and then repeated measures. The first box that pops up requires us to define the number of levels for our repeated measures factor. So this we call noise. If you remember, the thing that changed in each of the conditions was the noise. So we'll put that in this box here. And how many levels did we have? Well, we had quiet, medium and loud. So we had 3 levels. And we click Add. Then we can click Define. So the next screen, this requires us to specifically define what these variables are. So we know that we tested each participant in each of these 3 different conditions, so we just need to tell SPSS this. So you move each variable across from this box here into the within subjects variables box. So we'll put quiet, medium and loud. Now we want to tell SPSS that we want to run post hoc tests. So to do this, we need to click on Options and then move across the factor that we're interested in, which was noise, into the Display Means For box. So you just click that one across and then click Compare Main Effects. And in this drop-down menu, you can select which of the adjustments you want to make. So we're going to go for Bonferroni, so that's that one in the middle. We also in this box can ask for the descriptive statistics to be displayed along with other things. So we'll click on Descriptive Statistics here and then click Continue. If you're using a newer version of SPSS, so SPSS 25, where you have all the different options here, slightly different. There's a box, I think it's about this one, the third one from the bottom, and it says EM means, I think it is. That's the one you would select to give you the options that we get within this options box. So just bear that in mind. It's the estimated margins and means box here. So once we've done that, we can click on OK. And here we have the outputs. So we've got a number of boxes, like with all SPSS outputs. The first just literally lists the groups within our factor, so we've got quiet, medium and loud. The second is the descriptive statistics table. I think it's always really useful to have this in your outputs, so you can see the descriptives for each of these 3 conditions, mean and standard deviation. And then we've got the multi-release test for seriferacy, that's here. This is used to check one of the ANOVA assumptions. Have a look back at the video that I made about this, but without going into too much detail, it is not significant. We can see that here. So with it being not significant, we assume that we've not violated this assumption and we can proceed with the ANOVA kind of as we would. So moving on to the next table, that's this test of within subjects effects. This tells us if there was an overall significant difference between the mean recall scores of the participants in the different noise conditions. So this is one we're interested to know whether the noise had an impact on recall of words. Because we assumed seriferacy from this box here, this p-value here, 0.196, we read this top line. So where it says noise, seriferacy assumed, we're reading this top line. Had this assumption been violated and multi-list test been significant, we would make an adjustment on the degrees of freedom you can see here. So we would maybe read the greenhouse geyser, for example. But we're not. So looking at the F value and the significance level here, it indeed indicates that we do have a significant effect of the noise level on the number of words recalled. So our p-value is 0.001, which is less than 0.05, so it is significant. So because this is significant, we can now scroll down a few tables to the pairwise comparisons table. This reports the Bonferroni correction post hoc test, and we can look here specifically where the differences actually lie. So we focus on the p-values here, so it's just off centre of the table. So we can see we've got our condition numbers here, so they're numbered 1, 2 and 3, quiet was 1, medium was 2 and loud was condition 3. And we can see from this table that between conditions 1 and condition 2, there was a significant difference in the level of word recall, so the total number of words participants recalled between conditions 1 and 2. And the same between conditions 1 and 3. You can see that here, 0.003. If we look at condition 2 and condition 3, there was no significant difference between the number of words recalled here between the medium and the loud condition. So what does this tell us? This tells us that students were better able to recall words when there was a low level of noise, so in condition 1, but the medium and the loud levels of noise produced a similar amount of recall. So let's have a look at how we report these results in APA style. As I always say, it's key when writing up to mention the type of test conducted, the variables or the mean scores, and the standard deviations of the tests, and the outcome of the analysis with the correct test statistics. You'll see that I've got quite a simple format to report the results here. It's not uncommon to report confidence intervals and effect sizes, so just check the APA guide for whether you need to include these or not, and it'll depend on the requirements of your assessment. So just make sure you're looking at the university's guide as well. But this is kind of a straightforward way to look at it. So the results of our experiment. A one-way within subjects ANOVA was conducted to explore the total number of words students were able to recall in 3 noise conditions, quiet, medium or loud. The results indicate that there was a significant effect of noise level on recallability, and then we've got our test statistics there. Post hoc comparisons using the Bonferroni adjustment revealed that students were able to recall a greater number of words, that was 8.13, in the quiet condition than they were in the medium, and have reported the number of words and the p-value, and the loud condition, and again the number of words and the p-value. However, the difference in recall between the medium and the loud condition was not statistically significant, and I've reported that p-value there. So if we want to take a look quickly at where these numbers have come from. So we've got the results of the ANOVA. Where's our ANOVA table? Here. So the results of the ANOVA, so we've got our F value is here, so 11.761, and the p-value here of 0.001. We've then got the degrees of freedom. If you remember, we assume seriferacy, so we read this top line, so it's 2, and then the error creates the second part of the degrees of freedom, so it's 2,14. So that's our p-value. And then we can look at the descriptive statistics, which is up here for the values that we are putting in later on when we're actually discussing the exact number of words and the differences that we had. And then the p-values for the post hoc tests are here.